Okay, Assalamualaikum and good morning. Kita akan continue dengan part extra equation dalam 5.3 yesterday. Dan kita akan masuk 6.1 lah, iaitu new topic. Topic 6, that is discrete probability distribution. Okay, kita tengok dulu for the extra question, that means extra example for the 4 question in your 5.3 on your probability punya topik 5 lah. So we see for the first extra example for number 1. There are 12 red balls and 8 green balls in a bucket. So you ada 12 red and 8 green ball. Okay, 2 balls are taken out. So nampaklah kat situ you punya tree diagram is ada 2 cabang kan, out in sequence without replacement. So this is all that you have to read lah. Okay, and then the question also asks you by using tree diagram. So you have to build up the tree diagram first before you find the probability. So red, green. Okay, and then red, green, green, red. Okay, outcome dia akan jadi red, 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 green, 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 red. Okay, and then label the probability. Since that red is 12, so 12 over sample space you adalah 20. You add, so 12 over 20. And then green balls is 8 over 20. Since that is without replacement, so number of event akan berkurang, sample space pun akan berkurang. So let's say red balls will be 12, 11 lah, kurang 20, kurang also will be 19. Then you minus 1 minus 11 over 19, you got 8 over 19 for the green ball. Okay, so same goes for the second one from green. So green you take out without replacement. So 7 akan berkurang lah, 8 daripada 8 jadi 7 and 20 will become 19. So 1 minus 7 over 19 will be 12 over 19. So your tree diagram complete lah. So you got marks for that. Okay, so we see for the first question, find the probability that the first ball is red. So you want the first one is probability, first one is red. So you have 2 possibility, red, red, and also red, green. So calculate based on tree diagram, 12 over 20 times 11 over 19 plus 12 over 20 times 8 over 19. Okay, this one is the working step, and you calculate, you simplify using calculator, 3 over 5. Okay, and the second one, find the probability that the second one is red. If, so you have if here, if the first is red. So the word if, that means this is conditional probability. So probability of, sebab the event is the same, so red given red. Okay, so by using the formula of conditional probability, red intersect red divided by probability of given, that is red lah. Because this one is, the second one is red, the first one is red. Here is the first red. This one is the second one is red. But because of the event is the same, so dia tak akan bagi effect lah. Because you know that from the tree diagram, you take RR, red, red. So sama dekat sini, probability of RR is the one that you calculate for the probability of red, red. So you need to calculate from the tree diagram, you put as 12 over 20 times 11 over 19. Over probability of red is 12 over 20. Okay, sebab you ada satu je kat sini. Red given red. Okay, so you calculate, you will got 11 over 19. So that will be your answers. Okay, so that is for B. Then we go for C. C, the second one is red. Ada perkataan if juga, condition probability. The first is green. So this one, the event is not the same lah as just now. B, red, red, right. Untuk C ni kita ada red, tapi given probability is green. Okay, noted Hazel. Nanti mana tanda kat file. Okay, so C, cari probability of red given green. Okay, sebab kat sini dia kata the probability of the second one is red, but the given probability if the first is green. So this one is your given probability. First green. Second one is red. Based on the word if. Conditional probability lah. Then you use the formula of conditional probability. Red intersect green divided by the given probability green. So calculate. So refer your tree diagram. Okay. Ini pun samalah. Sebab you ada dua kan. Red green, green red. So dekat situ you kena tengok dengan hati-hati. Because of your given probability is green. So come marks. Dia akan dapat daripada sini. Ini. The given probability is green. So the first one. Ini sebenarnya are conditional probability given green. Okay, jadi jangan ambil 12/20 kali dengan 8/19. Tu salah lah. So here, kat sini kita boleh tulis kat sini sebab kita ada dua, RG dengan GR. That means R intersect green or green intersect R. Tapi kat sini, your first one is green ball. So should be given probability for this one is R given green. So you akan ambil 8/20 kali 12/19 divided by probability of green 8/20. Okay, and you calculate, you will got 12/19. Okay, itu untuk C. Lepas tu terbaca D. The second one is red. So, second one is red. You ada dua possibility. Red, red plus green, red. Okay, sebab daripada you punya outcome, second one is red, you got red, red and also green, red. So, you kira lah based on tree diagram. For red, red, you got 12/20 times 11/19 plus 8/20 times 12/19 based on green, red. Jadi ambil dekat situ, since that you punya tree diagram tu dah penuh, then you kira, you dapat 3/5 as the simplest form of the value probability. Okay. Lepas tu E, the first one is red if the second is red. So sama, event dia sama tapi dia conditional probability lah sebab the word is if kan, given. So you want to find probability for red given red. Conditional probability lah. Okay, so sama probability of red intersect red divided by the conditional probability formula divided by the given probability red. So untuk red intersect red, kita memang ada satu je lah, RR. Okay, so sama 12/20, 11/19. So samalah 12/20 kali 9/19 divided by probability of red 11/19. So your answers would be 11/19. Okay, jawapan ni similar dengan jawapan B. Cuma bezanya given ni adalah second red. Ini adalah first red. And for B, first one, the given one is red. The probability that you find for the second one is red. Okay, tapi sebab because of your event for red intersect red dalam tree diagram tu hanya ada satu, so the value is the same. 12/20 times 11/19, then you will divide it by the probability of given, even though that is in the second ball. That is 11/19. So dapatlah jawapan yang sama dengan soalan B. Cuma dia punya event berbeza lah. The given one is, the second one is red. For B, the first one is red. Tapi sebab event dia warna sama. Okay, so that is for example 1 for the extra question. Then we goes to number 2. Okay, Ikra travel to work by road A or road B. So ini boleh jadikan A, ini jadikan B. Setting lah for the event. The probability that if Ivan choose road A is 1/4. So this is the probability for road A. The probability for Ikra is late for work if, so ada perkataan if, so maksudnya conditional probability lah. The probability that late that means you can put as L. If Ikra travels by road A is 2/3. Okay, so dekat sini you boleh determine that the probability of conditional probability given late tapi pakai road A is 2/3. The word from the probability that Ikra is late for work if Ikra travels via road A. Maksudnya dia bagi conditional probability for late given road A. So tu adalah definitions for conditional probability yang you keluarkan. Okay. And the corresponding probability if Ikra travels via road B is 1/3. So mana sama, dia late tapi dia travel road B. So late travel road B is 1/3. Satu dalam soalan dia boleh bagi dalam bentuk conditional probability. Tapi kita masih boleh bina tree diagram. Okay, even though the question doesn't say that draw tree diagram. So since that you got two event, road A and road B, and then you late dengan you tak late lah, that means L prime kan, ataupun L complement. So you boleh letting, tadi road A, road B tu adalah A dengan B, late for work, okay, doesn't late lah, that means on time. Okay, so kita buat dulu tree diagram. So you got road A, road B. And then using road A, you late. So dengan you tak late. Using road B, you late. Dengan you tak late. Okay, so then you take out the outcome. Okay, and put the probability value. So road A is 1/4. Based on the first given value, 1/4. So road B dia tak bagi. Tapi you know that the total probability untuk satu cabang ni adalah 1. So 1 minus 3/4, you will got 3/4. Okay, and then given already conditional probability of L given A. So itu kat sini sebenarnya. Betul tak? L given A is here. So itulah nilai yang you patut letak, iaitu 2/3. Sini 2/3. Okay, kalau you nak letak dia punya conditional probability, ini adalah sebenarnya untuk L given A. Okay, sama juga dengan L given B. So here it will be L given B. Terus letak dia punya probability. Kalau yang merah tu yang value for L condition probability given B tak letak pun tak apa. But you know that places for that probability value. Okay, so letak dia punya value 1/3. 1/3. So sama, dalam satu cabang total probability dia adalah 1. So here 2/3, here is 1/3. Here is 1/3, baki dia adalah 1 minus 1/3, 2/3. So you lengkap lah you punya tree diagram. Dan barulah you jawab soalan. Okay, what is the probability that Ikra is late for work on Monday? So dia nak probability late lah. Probability of late. So you want to find for A, probability of late. So you ada dua possibility. Satu you guna road A, you late. Dengan satu you guna road B, then you late. Then you kira based on tree diagram. 1/4 times 2/3 plus road B late 3/4 times 1/3. Okay, then calculate, simplify, you got 5/12. Okay, and then for B, given, ada perkataan given that Ikrar is late for work. So that will be your given probability lah in conditional probability. What is the probability that Ikrar travel via road B? So dekat sini you nak cari probability of B given late for work. Tu yang you nak cari. Satu kena baca soalan tu dengan teliti. Which one already occurred the event based on conditional probability. So B nak cari probability of B given late. So use your conditional probability for formula. Probability of B intersect L given probability of late. Okay, so probability of B intersect L, kita ada satu je lah event kat sini kan. Road B late. So you take from the tree diagram. 3/4 times 1/3 divided by probability of late. Late, this one you already calculate in your A. That is 5/12. Ini dah cari dekat A. From answers A. Because probability of late using road B or road A. Then you simplify, you akan dapat jawapan dia adalah 3/5. Okay, that is questions number 2. Okay, so it goes for question number 3. Okay, Natasha, Diandra, Azawati pack biscuit in a factory. Natasha packs 55%, dan Diandra 30%, Azwati 15%. So you boleh buat nama lah as notation NDA. From the batch allotted to them, the probability that Natasha breaks some biscuit in a packet. Okay Hajar, noted. The probability that Natasha breaks some biscuit in a packet is 0.7. So break some biscuit, you boleh letak as beras pula. Breaks biscuit. Okay, B complement, does not break biscuit. Okay. So break biscuit adalah Natasha break biscuit 0.7. And the respective probability for Dandra and Azwati adalah 0.2, 0.1. Maknanya dia break biscuit lah. What is the probability that the packet with broken biscuit found by the checker was packed by Natasha? Sebelum kita baca soalan, kita build up the tree diagram first. Okay, so you have Natasha, Diandra, Azwati. Okay, then break, doesn't break. Break biscuit doesn't break. Break biscuit doesn't break. Okay. Natasha pack 55%, 0.55. In percentage, you change to decimal point lah kan. Over percentage 100%. Diandra 0.3, Azwati 0.15. Bila you total NDA ni, Natasha, Diandra dan Azwati, you dapat percentage 100%, but total probability 1. Okay, then put the value for break biscuit from Natasha is 0.7. So baki dia adalah 0.3 because minus with 1. And then Diandra break biscuit 0.2. Okay, and then Azwati break biscuit 0.1. Then same minus, here you got 0.8, here you got 0.9. Sama buat outcomes. And B. Okay. So you complete your 3 diagram, then you'll be able to answer all type of question being asked lah in the probability. So bila kita baca soalan, what is the probability that a packet with broken biscuit found by the checker was packed by Natasha? So ada 2 event untuk conditional probability lah. So you nak cari probability Natasha, tapi found by the Natasha tu adalah yang dah berlaku dulu adalah biskut tu dah break. So the event broken biskut ni, this is given probability sebab the event already occurred first. Then the probability was packed by Natasha. So kat sini you nak cari sebenarnya adalah Natasha given break biskut. Bukan N intersect B. Satu kena faham soalan tu. Walaupun dalam soalan tak ada perkataan given atau if. But you have 2 event and the event of broken biscuit is already occurred. So that is conditional probability. So you nak cari sama probability of Natasha break biscuit using your conditional probability and Natasha intersect broken biscuit divided by probability of given broken biscuit. Okay, untuk N intersect B, you boleh cari daripada diagram. You got 0.55 darab 0.7. Correct not? But probability of broken biscuit, you tak tahu lagi. So, kena kira lah sebab you ada 3 orang kan. So, cari dulu probability broken biscuit sebelum you masuk dalam formula. So, broken biscuit, kita ada 3 orang kan. So, Natasha broken biscuit, possibility dia, Dendra broken biscuit, plus probability of Azwati broken biscuit. Okay, then you carilah 0.55, 0.7 tambah untuk Diandra 0.3, 0.2, untuk Azwati 0.15, 0.1. Kalau you nak terus masuk dalam formula ni, terus kira dalam ni pun boleh. Ni dia kira asing. So that mean tahu probability of broken biscuit tu berapa. Okay, so dapatlah 0.46. So barulah you boleh masukkan dalam this value. Okay, so probability of Natasha intersect broken biscuit, ya dah ada lah dekat 3 diagram tu kan, 0.55 darab 0.7. You divided by the probability of broken biscuit based on 3 person, Natasha, Diandra and Azwati, you dapat 0.46. Then you simplify, you press your calculator, you will got 0.878370. So that is the probability that a packet with broken biscuit found by the checker was packed by Natasha. Okay, and then we pergi pada last extra example in chapter 5. Satu kena baca betul-betul lah soalan probability dalam chapter 5. Kalau dia tak ada keyword of given dengan if, you kena faham soalan tu which event is already occurred. So that event already occurred will have that value as given probability, or if, then soalan tu nak conditional probability. You salah faham, then salah lah you punya probability value that you count. Okay, so kita tengok pada soalan nombor 4. According to the firm's internal survey, for those employing living more than 2 miles from work, so ni event dia lah, as 90% travel to work by car. So ini 90% work by car. So C lah kan, buat dia punya notation. The remaining employees only 50% travel to work by car. And it is known that 75% of the employees live more than 2 miles from work. Okay, kalau you nak buat, you let first the operation. So more than more than 2 miles is your B. Sebab living more than 2.5. Nak buat penuh pula sekejap. Living more than 2 miles from work. Okay, ini 2 miles sahaja. Living. Tak ada perkataan living. Living 2 miles from work. So Madam letkan A tu adalah living 2 miles from work. B tu adalah living more than 2 miles from work. Okay, and then you ada pakai car dengan tak pakai car lah. So tambah kat sini work by car. Okay, this one kalau you faham, you tak perlu tulis lah. This one I explain what is the notations that I put in my tree diagram. Okay, so kita ada dua. Kita bagi employees living more than 2 miles from work dengan yang lebih daripada 2 miles. So, kita ada A, kita ada B. Lepas tu yang pakai living 2 miles tu dipakai car ataupun tidak. So C complement. C complement. Okay. Daripada you punya statement in your question, 75% tu yang live more than 2 miles from work. So 0.75. So 0.75 dekat B. Sebab B adalah living more than 2 miles from work. So sama, untuk living 2 miles from work dia tak bagi, tapi kita boleh tolak 1 minus 0.75. Kita akan dapat 0.25. Okay, and then dia bagi dalam dia more than 2 miles from works, maksudnya given probability dia adalah 2 miles from work kan. Dia bagi 90% work by car. So dekat sini sebenarnya dia bagi probability of, given probability is B, that means living more than 2 miles from work, tapi dia work by car. So ini adalah 0.9. So you boleh letak kat sini 0.9. Ini adalah C given B. So 0.9. So 0.9. So sama, 1 tolak 0.9, 0.1. Okay, so 0.1 here. Okay, lagi satu dia kata remaining employees only 50% travel by car. Work by car lah. That means baki employees you yang living 2 miles from works lah. So 0.5. So sini 0.5, sini pun 0.5. 0.5. Ayat ni. Okay, the remaining work by car. Sini lah. That means here is actually the given probability is A work by car 0.5. Itu yang dekat sini. This is C given A. Okay, so bila dah lengkap, then write the outcome. Then you calculate based on the equation probability that asked. So first, determine the overall proportion of employees who travel to work by car. So dia nak probability of car. Tak kisahlah dia live 2 miles from work ke ataupun more than 2 miles from work. So you nak cari untuk A, probability of car. So dia ada 2 possibility lah. That is AC plus BC. You kira you dapat 0.25 daripada tree diagram darab 0.5 tambah 0.75 darab 0.9. Calculate, you got 0.8. Okay, 0.8 is probability. Tapi your question is overall proportion. So bila overall proportion adalah percentage. Macam ni lah dia bagi percentage but you turn out to probability value. So jawapan akhir dia bukan 0.8. Jawapan akhir dia adalah overall proportion employees who travel work by car is 80%. That is the final answer. Because dia nak jawapan dalam percentage kan. 0.8 times 100 will give you 80%. Kalau soalan tak tanya based on percentage, then the answer will be in probability lah. Kalau tak, you hilang markah 1 lah. As you just answer in the value of probability. Okay, itu untuk A. Lepas tu B pun sama. The probability that an employee who travels to work by car. So ada 2 event kat sini. Live more than 2 miles for work. So this is conditional probability. Walaupun tak ada perkataan given ataupun if. Tapi kalau tengok kat sini, which event happen first? Adakah living more than 2 miles for work atau work to car? So dia nak probability employee who travels to work by car. So itulah probability yang berlaku dahulu. This one is the given probability. Ini given. Okay, and then live more than 2 miles per work. Kat sini dia nak cari probability given B given C. Itu yang dia nak cari. So your car is your given probability. So B. Yeah, Alvin, ada soalan? Alvin ada soalan? Awak raise your hand tu. So using your conditional probability. Tak ada soalan Alvin? Angkat tangan. Okay, so using your conditional probability, probability of B given C, that means probability of live more than 2 miles from work given work by car. So cari guna conditional probability adalah B intersect C divide by probability of C. Okay, B intersect C kita dah ada daripada tree diagram lah ini. 0.75 times 0.9. So 0.75 times 0.9 divided by probability of C, you already count in A. In A lah, 0.8. Okay, so calculate, you will got the value of probability 0.8438. So that is the probability that employee who travels to work by car lives more than 2 miles from work. Satu soalan tu kalau tak ada perkataan given dengan if, you kena tengok hati-hati. Untuk A, sebab dia tak ada perkataan probability. Dia nak cari overall proportion of employees who travel to work by car. So nak dalam percentage. Tapi cari probability tu dulu. Okay, so you have to read carefully for chapter 5. So that is the end of chapter 5 punya soalan. Ada 4 extra question. So habis dah chapter 5. So kita pergi pada pengenalan iaitu introduction in chapter 6. So kita tengok dulu. Okay, this is the learning outcome for topic 6, discrete probability distribution. Still in topic probability, maksudnya pengenalan tu dah belajar kat chapter 5, tapi dia akan pergi lanjut using distribution. Distribution adalah table lah ataupun formula. So topic 6 kita akan pergi kepada discrete probability distribution. So kita pergi pada 6.1 dulu hari ni, the introduction. So you have to define the random variable and identify the discrete random variable and continuous random variable. Hanya identify sahajalah. And define the probability distribution. Cuma you akan tak belajar, exclude means not included lah. Exclude kita tak akan cari mean, EX ni mean lah. And mean kuasa 2 and also variance untuk data probability distribution you. Okay, so dia excluded lah kat learning outcome tu. So tengok pada introduction. So kita ada random variable, a variable whose value a real number depends on the outcome of random experiment. Okay, itu random variable lah. Okay, discrete sebenarnya dah tengok dekat topik 4, you ada discrete and continuous kan. So sama, cuma dia dalam bentuk probability. So discrete random variable adalah random variable that assume a countable value. Maksudnya nilai yang boleh kira lah. So same konsep dia masa dalam discrete chapter 4 yang boleh dikira. So as whole number, for example, number of student in KML, number of cars sold in a month, number of accident in a year. That is considered as discrete random variable. Lepas tu continuous random variable adalah a random variable that assume any value contained in one or more interval is called continuous random variable. So maksudnya dalam bentuk bukan whole number, perpuluhan, tapi still countable. Cuma akan ada perpuluhan lah. Contoh weight kan, weight of student, kita ada whole number dan kita ada juga perpuluhan. Time taken pun sama, the head of person pun sama. Tapi number of student in KML tak mungkinlah perpuluhan kan. Ataupun number of car, ataupun number of accident. Ini whole number. So beza antara discrete random variable dengan continuous random variable dalam tajuk random variable. Okay, so kita tengok pada example. Example 1. Indicate which of the following random variable are continuous or discrete. So ini hanya nak kenal pastilah. That's why you have to define, you have to understand the learning outcome as to define which one is discrete, which one is continuous variable. Tapi yang ni more or less akan keluar kat UPS lah. PSPM tak akan keluar macam ni ya. PSPM is penyelesaian punya soalan. UPS ya. Okay, so life of battery, continuous or discrete? Continuous kan? So continuous. Macam ni je continuous. Continuous. UOUS. The number of new accounts open at the bank during a certain month adalah discrete sebab tak mungkin ada perpuluhan, betul? So discrete. Okay, and then time taken to run a marathon, continuous. Sebab dia tak boleh jadi whole number lah, dia mungkin akan jadi perpuluhan. The price of concert ticket pun sama sebab duit kan, duit mesti adalah perpuluhan. And then total weight also continuous sebab ada perpuluhan juga. Number of student in school, ada perpuluhan tak? Tak ada. So it's discrete random variable. Discrete je tak betul. Time spent by student in answering question, continuous. Sebab masa ada melibatkan perpuluhan. Height of student pun sama melibatkan perpuluhan kan. So is continuous. Continuous. Okay. Number of room in house, ada perpuluhan tak? Number of room in the house, tak ada kan? So is discrete. So tahu macam mana nak bezakan continuous random variable dengan discrete random variable. Discrete random variable maksudnya mesti whole number lah. Tak akan berlaku data tu ada perpuluhan. Okay, then we goes to the last part for the example 2. probability distribution. Probability distribution ni pernah tengok masa tajuk yang kalau you ambil M-Maths lah, you bina table kan based on probability sebelum you guna formula NCR untuk binomial punya formula. Okay, the probability distribution of discrete random variable lists all the possible value that the random variable can take and the corresponding probabilities. So, two characteristic of probability distribution sama macam dalam tajuk chapter 5, kita ada basic, 4 basic probability yang kita kena tahulah. Total probability, nilai probability tak boleh negatif, nilai probability is between 0 and 1, total probability is 1 kan. So, same goes for probability distribution. So the value for probability discrete tu mesti positif lah, cannot be negative from 0 to 1, and the total probability must be equals to 1. So konsep dia masih sama, cuma dia dalam probability discrete. Kalau chapter 5 probability based on you punya variable ataupun Venn diagram, tree diagram ataupun contingency table. Tapi sekarang based on discrete. X lah discrete tu. Okay, so probability function, kita akan tulis dia sebagai inilah probability of X discrete X. Maksudnya discrete you akan sama contoh start daripada 0, 1, 2 dan sebagainya. So that is probability distribution function. Can be given in the form of table or mathematic formula or graph. So kita ada 3 jenis lah. Table, mathematic formula. Mathematic formula maksudnya dia akan bagi dalam bentuk summation lah. Dan juga graph. Kalau chapter 5 kita bina penyelesaian tu, kita boleh guna tree diagram, contingency table ataupun Venn diagram. Kita pada example 2. A fair die is thrown and the number of the die is the random variable X. Construct a probability distribution table. So X tu adalah number on your dice. Okay, die, bukan dice, die. Okay, satu dadu sahaja. So number of die tu adalah discrete U. So kita akan bina table. This is only introduction lah. But basically you know how to build. So discrete U adalah dalam dadu start daripada 1 bukan 0. 2, 3, 4, 5 dan 6. Okay, and then this is probability of you punya function. P X equals to X. Okay, so probability untuk getting number 1 from sample space 1/6. Satu pengetahuan tu dekat chapter 5. Tapi you build in the probability distribution table. So 1/6. Ini pun sama. 1/6, 1/6, 1/6, 1/6. The outcome lah 1/6. Bila you total probability ni, maksudnya dalam bentuk math formula, probability of discrete, bila you total up, you akan dapat satu, dua, tiga, empat, lima. Now you akan dapat 1. Atau bila nanti kalau dalam soalan dia bagi huruf, dia suruh cari tahu total probability discrete adalah 1. But you semak based on your outcome of your discrete. Okay. So that is for number 1. Then it goes for number 2. Bila you ada huruf function lah. That this is mathematical formula. So dia bagi probability of X is equals to AX for discrete 1, 2, 3 and 4. So kita build table first. Okay, so kita masukkan untuk 1, kalau masukkan untuk 1, you sub X1, you dapat A lah. Okay, and then you masuk 2, you dapat 2A. You sub the value of X in the function AX. And then 3 pun sama, 3A, 4, 4A. Sub inside the function probability for AX. Okay, so the question asks you, find the following probability distribution function. Ini and find the value of A. So you want to find the value of A, so the concept of total probability is 1. So sama, kena tulis total probability equals to 1. So cari total up lah. A plus 2A plus 3A plus 4A sama dengan 1. So you got 10A equals to 1. Thus your A equals to 1 over 10. Okay. So itu introduction untuk 6.1 based on random variable and probability distribution. So binomial distribution benda akan pergi next week lecture. Ada soalan? Boleh follow. Okay, so kalau tak ada apa-apa, madam stop kat situ. Nanti sama soalan tutur selain daripada chapter 5, number 7 to 23. Kita akan go on lah untuk next week untuk kita fahamkan, dan after finish tu in the middle madam akan buat quiz lah for chapter 5. Walaupun kita masuk awal introduction chapter 6. So kalau tak ada apa, that's all. Thank you class. Boleh left.
Thank you, madam.
Alright.
Thank you.